So here's a base 4 that's positive and it's not 1. Remember, if we have f of x equals 1 to the x, we really just have the equivalent of f of x equals 1, which is a straight line and not an exponential function. How do we evaluate this? Well, any base to the 0 power is 1. 4 to the 1 is 4. 4 to the second power, remember, is 4 times 4, which is 16. Now, if I take 4 squared and I multiply that by another 4, I'm essentially, if you think of this as a geometric sequence, I'm just multiplying by my common ratio again. 4 times 4 times 4 is this times 4, which is 64. Those are fairly straightforward. How about 4 to the 1/2? Well, we have to remember that a to the 1 over n is the nth root of a to the first power. In other words, this here, this numerator, represents the power. And this denominator of a fractional exponent represents the root. So I'm really taking 4 to the first power, and I'm taking the square root of that. Of course, that's true. How about another tricky one, like 4 to the -2? Well, remember that if we have a to the negative n, that's the equivalent of 1 over a to the n. So this is 1 over 4 to the squared power, which of course is 1 over 16. Just a quick review of some key points with exponents. So this is fairly straightforward. It says, use a calculator now to evaluate each function at the indicated value of x. F of x equals 2 to the x, where x is negative 3.1. So f of negative 3.1 will be 2 to the negative 3.1, which of course is the equivalent of 1 over 2 to the 3.1. Well, I know 2 to the third is 8, so this is close to 1/8. When I punch this in my calculator, 2 exponent negative 3.1, I get 0.1166291, which I know is close to 1/8, which is 0.125. So because my brain can do this calculation as well, I know I'm on the right track. F of x equals 2 to the negative x, where x is pi. So f of pi is going to give us 2 to the negative pi. Again, I see negative exponents. I know this is the equivalent of 2 to the 3.14, which is about 2 to the third, which is again close to 1/8. And if I'm thinking about 1/8, I know that's 0.125. When I put in my calculator 2 to the negative pi, I get 0.1133147, which is again close or fairly close to 0.125. I'm on the right track. Here we've not violated any rules because we know that f of x equals a to the x, where a has got to be a positive number. Remember, a has got to be greater than 0 and a can't equal 1. And x is a real number. Well, this is the equivalent of 1.5. So I know that I can do this. According to my rules, this is fine. So f of 1.5, or 3 over 2, is 0.6 to the 1.5. So in my calculator, I'll do 0.6 exponent 1.5. And when f of x equals a base of 1.05. Well, as long as this is positive and not 1, we're good to go. Now our exponent is 2x. So f of 12 would be our base 1.05 to the 2 times 12, which is the equivalent of 1.05 to the 24th power. So when I put this in my calculator, I'm going to write it like this. And when I do, I'll get 3.2250999. And there's our answer.